Hi DevOps community, we are pleased to present you our talk and our project about AI agents and BPM, BPM, Business Process Management. And more precisely, we'll dive into how to build a trustworthy AI module and how to integrate them in our process, about insurance process. But before to jump into the content of the presentation, we wanted to give a bit of context. Jan will present with me. He's hidden in there, but he will come on stage. Don't worry. We both work for Belfius, the insurance part, and we are really proud to work for this company, especially because we don't just use AI. There is really a management and a vision with some strategic partnerships with Alan, which is an AI for health, and with Mistral, which is a bit the Europeans' concurrent to ChatGPT. So the agenda of today. Our goal is to automate our process. Why we want to automate our process? Because we have too much workload on our team, and we want that our experts, our claim handler, focus mainly on where they have added value. We will do the presentation in two parts. Jan will present the AI module, how we build nice AI agents, and I will present how we integrated them in a robust process. Our goal for both presentations is the same, is to build trust. Without trust, we lose the confidence of our colleagues, claim experts, but also of our customers. So Jan is our Gen AI lead, is using evil language called Python, and I'm the software engineering working. I'm also in the lead of the Belfius Java community, using this good old Java language. Before to give the floor to Jan, I wanted to stress out our intent, and I think you feel it during the DevOps. The things we are changing quite fast, especially with AI, and we will request more and more to developers to have other skills. And one of important skills to have is to express well the requirement. And we saw talk, there is a lot of talk about that, of specification driven development, or also called a prompt driven development. And it's all about writing good requirement, and then it will maybe generate an application. But anyway, we need to have a good skill of expressing requirement, and this talk will be about also this focus, how to make visible those requirements to the business. And I will make the link to Jan now. This goal, you have a lot of talk about agentic AI, of how to build AI model, and now our talk will be how we use AI agent in the real enterprise environment.
Right. Thank you, Nicola. So our talk is about text in, text out, and I guess almost every talk at DevOps this year is about this kind of processes. But I'm not talking here about an LLM, but I'm actually talking here about an insurance process. So, like I guess many of the service industry companies, but we actually just deal in text. Customers send us images, text about what happened to them. We think about it, and we answer with a decision, either money or some other kind of help to fix their problems. This process of customers sending us texts and we answering with an answer is not a one-shot process mostly, and it's something that we identified at Belfius, I guess every insurance company. The beginning of a claim is a very iterative process. A client sends something, we need to ask some more details. That triggers, again, more questions. And the beginning of a claim can sometimes take multiple days, multiple weeks. And it's both for us inefficient, but also for the client not very nice that they have to answer a lot of questions over a time span of sometimes days or weeks. So that's why we, as an AI team, together with technology, we've been focusing on trying to reduce the number of loops and the time spent in these loops. For this, we're building some AI components or AI agents to be more with the theme of the conference. And especially since the rise of Gen AI and LLMs, a lot of these AI use cases or agents became possible from going from maybe a project that would take us months and a team of 5 people to things that we can build sometimes in days or weeks, and that we now have so many more options to actually have impact on the actual business processes. In this talk, I will go deeper into some of the components, like, for example, claim coverage, where we'll try to help the claim handlers decide whether a claim is covered by the policy of the client, yes or no. Or, for example, completeness, where we will try to, when documents come in, already check automatically, do we have all the information needed for proper claim handling. But before I go into the talk, I'll give a small demo of our current Claims Copilot, which is a tool that we are building to assist our claim handlers. So the first thing that you see is we make a summary of the claim. So a lot of documents, as you can imagine, come in. Sometimes claims have hundreds of documents. So the first use case, and I will go deeper into it later, was just making a summary of all the structured and unstructured information that come into a claim. Another agent we're building is the client impact agent, which will try to detect if a claim really has a big impact on a client. We want this to be high priority for us and also to be kicked out of the automatic process. Then completeness, which sounds a bit boring, but actually is one of the things that will speed up the process the most, to automatically, at the time when documents come in, check them for completeness and, for example, send a question to the customer, we're missing still a picture of your television. The claim coverage that I mentioned before, for example, where we try to assist the claim handlers in formulating coverage advice or decision to the client. And then lastly, we're also building an AI component agent that estimates the costs of the claims and updates this estimation as more information becomes available. But so now in this talk, I'm going to focus on how that we approached building these agents, and I'm going to be focusing mostly on the process around it and what some of the early lessons learned. And I'm not going to go deep into the actual agentic stuff, because I think a lot of the talks already today, language chain and stuff, already have covered that. So we wanted to be adding to that instead of just repeating the same agent definitions all over again. So first, a bit of the history of the project. We started with building first a claim summary. Why? It very early became obvious that LLMs were very good at summarizing stuff. And so we saw the pain at the claim handler side that often when they had to do takeover work from their colleagues, they had to sometimes spend hours, or 2 hours, reading the very big claims when their colleagues are on holiday, for example. And with this tool, we very quickly had traction among the claim handlers because we had discovered a very obvious pain point, and we could deliver something that pretty quickly was of decent quality. This then enabled us to build the foundations on which all the other agents are being built. We identified 3 main foundations. First of all, of course, we need to connect to the data. So making the connections between where we run our Python stuff to the corporate systems. But the 2 most interesting ones that we discovered that really were like an enabler for accelerating our agent development was building the Claims Copilot, so an interface where we can expose our AI components and agents to the claim handlers. And secondly, it's the most AI technical part of the day, where we built a context library. But I will go into much more detail after what it is and why it enables us to go much faster. First of all, building a summary actually was a pretty easy use case because very short, we just get all the information, we transform it into text, and then we ask the LLMs that we use summarize this information. That's easy. But for example, if you then go to the next step that we're now doing, building the coverage components, of course, the claim handlers can explain us how the process works in general, but there are so many nuances and gray areas and edge cases that it's almost impossible to upfront write all the specs that we need to implement for the coverage decision. And so that's why we are taking an approach where we deploy these agents to a select group of testers in the Claims Copilot. We have also a lab edition of it, Claims Copilot Lab. And then these claim handlers will use these features, give feedback, and then we can use this feedback as to enrich our prompt that we use to, for example, decide coverage. It's a bit in the, I think most of you know this comic, that it's much easier for people to give criticisms or say this is wrong and why, then just upfront define all the different rules and things we need to implement. For this, we invested quite a lot into making our interface nice and ready to enable this process and to have a kind of a data flywheel where, for example, we can expose different versions of agents to the claim handlers and they can then say, okay, agent A answered better, so we're gonna improve this one, or we can test different approaches next to each other. Also, of course, we always feedback is the most important when you're developing these agents, and so we try to make it as easy as possible for claim handlers to give feedback on the output we generate. So then we have our prompt, so the more classical prompt engineering. Secondly, it's super important that we create the right context in the prompt. So what I mean by that is we need to structure the data that we have in our system, so the structured data from the classical claim handling software, all the unstructured data, so all the images, the documents, the mails, and we need to transform them in a way into a LLM-readable Markdown file that then we can use to feed our different agents. And this part, and so on the left, we start with all the different documents and structured information. First, we transform it into a big claim event table, we call it. And then we apply different kind of transformation on it, and we extract different kinds of information out of it. So, for example, we extract all the damaged items of a claim, we extract all the persons involved, or we reuse a claim summary that we also use to help the claim handlers. And this, we invested quite a bit of time in making this a very nice process that our claim agent developers can reuse to very quickly create value. And their job then is to exactly, for every business case, for example, client impact, they only need to reuse the claim summary and the person in claim, which means that this agent or AI component, it's a pretty simple one, can run very quickly and very efficiently. While, for example, completeness, that needs to connect to the real raw documents because we really need to inspect, okay, is this picture clear enough? And then we need to first find the communications with pictures and then extract the picture and ask a proper prompt. For example, then also coverage. That is one of our more advanced agents at the moment, which combines a lot of different levels of the interior, of levels of processedness of the claim context library. Of course, then we build these agents, and then the next question that we, at the moment, are investing a lot of time in and discussion with business is, what do we do with them now? And at the moment, we have identified 3 options how we can use them and actually create business value. We can either support humans or we can automate. But even in the supporting humans, there are different levels of impact these agents can have. For example, I'm going to keep using coverage as an example. Coverage, we can either use it as support. So, for example, we supply them with the claim summary and the highlighted policy clauses which might be relevant, or we actually already propose an email to the client. Or then, in the dream scenario, sometimes there we can also say we're going to send automatically an email to the client. As you can imagine, this is a process which needs a lot of discussions and business decisions because we cannot just throw these things into production because there are sometimes high impact both for us internally or for our clients. So that's why we're setting up a process where we have a gated promotion process. So all agents start as a shadow of the claim handlers. So in the claim lab, where we say, okay, we need 3 people to test our new AI agent, the coverage agent. They just do their work as normal, but then we ask them next to their normal job to also check out the output that we generate and give feedback. Then once we meet certain success criteria, for example, is it accurate enough? That's an easy one. What's the cost of an error if you would be wrong? How will we deal with errors? Who will correct this? And then we are setting up a process where then every agent can get promoted from shadowing to assist, to propose, to automate. And of course, every time we go higher in impact, the criteria become more strict and more and higher. So for example, now at the moment, our summary is assisting, because there's also no action that it can suggest. But coverage and cost and client impact, we're running now in shadow mode, so there's no impact on the clients, but we are learning and we're getting more and more feedback, and our agents become more accurate. But then we can see, for example, for some agents, maybe it will take a few weeks or months before they're mature enough to be promoted to assist, where then they will assist all the claim handlers. And then after a while, we then can also promote them to a propose mode or an automate mode. There's another layer to this discussion. Of course, there can be agents which are powerful enough, but still, in some scenarios, you never want automation just always to happen. For example, you could have claims which are so important, either because they're about so much money, or because they involve some people that we don't want to treat with AI. Or it can also be that some claims are so complex that our agents should warn us and say, I'm not very certain of the answer, I want human fallback. Also there is another interesting thing that we're now exploring. Imagine our agents give a warning, okay, I'm not certain about the outcome, we want to escalate. And then we can also see scenarios in which, based on the maturity of the claim handler, is this junior, then we're just going to maybe assist, because we maybe want him to actually read the claim, read the policy documents, and formulate his own thoughts, while more senior persons, they can maybe be trusted with propose, and they can just click OK when they approve of our proposal. And so that's where I go back to Nicola. It's very clear at the moment we're taking an approach where the agents we build, they are mostly in read mode, so they read the documents and they formulate an advice. Then we decide in business, how are we going to operationalize this advice? Are we going to assist, propose, or automate? And if we automate, then still we just give our advice, and then it's the role of business together with IT to define the proper rules when this advice will be used in practice.
Thanks. So now that Jan explained how to build a nice AI module by phase with a copilot and with feedback with the business, we'll jump inside how to link those AI modules with the general process. We'll zoom out. And for that, we'll do orchestration and we'll use workflow engine. To make a link, I don't know if you had the chance, the luck to do orienteering run, but it's a bit the same principle. You have point of interest, like the AI, some AI agent, but it could be also our good old application with REST API. And now the goal is to link them together and to put some rules on the link. So to come back a bit on the why, like I explained in the introduction, the workload on our team is really too high, and we want that they have more free time to focus on added value. I mean by that, in our ID, when the expert, the claim agent come in the picture, they should have all the information in their hand, and they should only make a decision based on that, and not starting to request extra information like a policy ID or extra picture for the damage, to explain the damage. We want to automate, yes, but in a robust way. And what I mean by robust, and I will make a link now to Olivier Armand, it's a French biologist, so no link to IT, but still he did some study how plants on plants, and he make the link with how our human system are working, and he show up that we are in a world with a lot of change, a lot of we're in a fluctuant world, especially now in IT with AI, a lot of game changer. And for the robustness, I propose 3 pillars, and I will come back on those 3 ones. The first one is about visibility. The second one is about check and balance, and the third one is about adding human in the loop. So for the visibility, for the first one, we use BPM, Business Process Model Annotation. It's a graphical language, and it's easy to understand it. As you can see, you can just by reading the diagram, understand what it does. You have a start and an end, and you have some box, and the box represents a step, an action. And here, for our case, a simple version of our process, we receive and store the communication from the customer. Then, and I will zoom in it and comment later on about this sub-process, is we analyze deeply the claim case with the help of AI agents. Then we move to the pay the customer, it's the happy flow, and we close the claim. And like in orienteering race, you have a legend, a map legend, to have specialized elements. And in BPMN, you have also specialized element to express your need. So the three main one is the first one is the task, the box that you saw, and those box can be the different type. The user task, where we expect really manual intervention. It could be a script where you start Java, for example. Service task, where you call an API, or another Java service. And business rules, I will come back later on it. The other type is the gateway. It's really the routing part. It can be a simple one, or it can be parallel call, or exclusion, inclusion, and so on. And you have the event. The event can, like I showed in the previous slide, it could be a start or an end event, but it could be also a message that you send to another process. And by doing that, you can use, for example, a Kafka queue with an event. And you have also other type like error, and then you throw an exception, for example. I say I will come back on the business rules task. So you have other sub-language. This one is called DMN, Decision Model Annotation, which is also a graphical language. And like you can see, it's a table of truth where you can easily define the business rules. And you have another version, more geek version. It's the DRL, the rules rule language. It's almost like coding, but it's the same concept. It's to be able to express the business need and business rules. So how it's working? You have multiple phases. You have the first phase where you design, where you express your requirement. Then you model it with the graphical language, BPMN. Then you execute it in production. Then the next step is an important one for us, is the monitoring part, where we'll use Kibana, Grafana to see how it's working and to have feedback, and then finally be able to optimize our process. What we saw is that we are working more and more with a specification-driven development. We could perfectly use an AI, for example, to express our requirement and then to request to generate the graphical model, the BPMN, go to the business to show it to the business, to have a validation with the business. Is it what you was expected, to show it to the whole team, by the way? And so everyone is aligned. What is really powerful of BPMN is that it's visual. I said I will come back and zoom in on analyze deeply the claim case. There you can see every steps, and that will make the link with the AI module of Jan. The first step we will evaluate the completeness by calling the AI. And if we see that we miss a document, we'll send a communication to the customers and come back later. Then we'll verify if the claim is covered, because if it's not covered by the insurance, it doesn't make sense to continue. Then we'll call another module, also an AI module, where we'll try to determine to find the cost. And based on the cost, we'll make some decision. It's there where it's nice to have BPMN to express it. And for this example, this simple example, we say if it's above a certain amount, we want always a manual validation of one of our experts. If it's less, we go to the next step, which is we'll try to detect potential fraud. And if we have a fraud, then we raise an exception. Here the demo, I will come back on it, I will use Cogito, but what is nice with Cogito is that you have a console, but you can use other tools, of course, but the principle is that what is nice with BPMN, you have the strength is it helps you during the design, but also during the runtime where you can see in live where you are in the process, and you can see in which step you are. The input and the output of the process is really nice for debugging, for example. And like I say, in the flow, an important step is to have monitoring. And here it's a real example with Kibana in production, but you can also use Grafana. Here you will select the KPI you want. Here it's about volume, but you can have the average time to finish, the number of active process, the number of human tasks running, as you want. So that was the first pillar about visibility. The second one is about check and balance. Here we'll what is good is to have loop and fallback scenario. Like I explained, for example, for the completeness, the fact that we think to have a loop and multiple communication with the customer by sending email to them. And you have also the fallback. Yeah, for example, if we think that there is a potential fraud, we throw an exception. In our vision, AI always advise, and we really need strict rules above it. And to do that, we can draw it in the BPMN, but we can use DMN or DRL to have more nuance to express the business rules. Of course, I speak a lot about interacting with the AI module, but we still use our all good application, and we hope that there are also some checks, for example, that we cannot create twice the same claims. And if it's not the case, we need to design it in the process, of course. Last but not least, you can write testing. I will show some example later on. And here, this example I use, it was about the cost. And I guess you already heard, if not, about the case of Air Canada. They have a chatbot, and one of the customers was able to have a really low price, but Air Canada was obliged by the law to keep this price really low because they consider that Air Canada was responsible of the reply of the chatbot. So now the last pillar, human in the loop. For us, the human is really important that it come in the picture for really the expertise and for emotional context. For example, if your home burned down, maybe you don't want to receive an email to ask you extra document, you prefer to receive a call. And for us, another important rule is that human overrule AI. I mean by that, if an expert come and gives his expertise, we don't want the AI come after and change the data. So for the demo, I use Cogito because we use at Belfius Red Hat product. What I like with Cogito is you have the full context with a lot of tool linked to Cogito, and Cogito is container ready. I will show it during the demo. It makes you able to create little package, and you are able to ship it easily on the cloud. So Cogito is in two parts. You have the part where you design really, like I show with the BPMN. And then you have the second part where with Maven, you will start Cogito and it will generate, and there you have the shows, or a Spring Boot application or a Quarkus application. And you have, like I said, a lot of tool links to the Red Hat context, like Kafka. I spoke about sending a message between process. You have in-memory database. You have a single sign-on with a key clock and so on. And I spoke already about Grafana and a lot of tools linked to it. Let's go to the first demo. Okay, so that's in Visual Studio Code, and here I am showing that I create a class called claim. With it's a classical Java class with properties, and I will use this class as a variable for each step. And like I explained, we have a sub-process, claim context, and that's the other sub-process with all the box, and all the box we call each time a service. Here I will show it's calling my service claim cost service with the method calculate total, and always you give the object as a parameter, and you can receive back the object. Here it's a demo, so it's a fake one, so it's generate a random cost, but in the reality, of course, it will call the real API of Jan, the AI. And here, like I explained, it's a simple version, but you can add some rules. If the amount that we receive is above a certain limit, we go in one direction or in other one, like manual verification. Voilà. So what I show, it was that was the first part where you design really the process, and now I didn't show, but you start your Maven, and it generates an API, and here it's a classical Swagger API, and what I will do, I will send a fake claim with the famous message lorem ipsum. And then I will show that it's arrived in the console. The process is active and not complete. Why? Because we went through all the box, all the tasks, but the amount is too big, and then we expect a manual intervention of an expert to validate the amount. Here, I'm doing everything with Swagger UI, but of course, you can build your own UI or use one of the Cogito task console. Like you can see here, the amount was too huge, above the limit, the threshold. And now I will just go and validate to complete the task. And it's based on, it's why I'm copy-paste the ID here. It's based on ID of the task and the ID of the process. Now I have another demo. It's basically the same principle, but this time it's calling DRL. to make a validation. And it's also linked to a Java class. And here, what I'm doing, I'm checking the emotional score, and it's above a certain limit. Then I'm expecting that a personal assistant come in the picture. So same principle, it generates Swagger, an API via Swagger UI, and I will send, I will trigger the process. And then here in this case, the emotional score is too high, so we go inside the personal assistant box, and we expect an intervention. Yeah, as you can see, it's active. We went to the personal assistant. And now I will go back and I will send an HTTP request to validate it. But as you can see, it's really visual. You can really nicely visualize it in Visual Studio Code. You can link it with your class, your Java, and you have the second part, the runtime, where it's a nice API that you can ship on the cloud. And I said I will speak a bit about testing. Here you can, it's an example with a Quarkus test where you can inject your person process, and you can send a payload of a person. It's a classical testing, and see the reply and check in the reply that is correct or not. Here it was a simple example. You have a lot of other examples. The QR code linked to Cogito repository will be on the last slide. You can, for example, in this example, you have Kafka. You can communicate between process. You can store the information, and you have Grafana. And I invite really you to check those examples. It's really nice to play with them. So the key takeaway is that the solution designer like to draw a box. No, that's not the case. Our main message is that above AI agents, we really need deterministic orchestration. We really need to check the output of AI, especially for us in the bank insurance sector. And to do so, we liked the way of combining AI and BPMN. We present you two methodology, Jan with the augmented first and then automated, with this nice copilot next to the business to have their feedback. And I presented the part about robustness with three pillars: the visibility, check and balance, and human. And our main goal is to always to build trust and to have the intention of the business visible. Our project just started. It will be a project for 3 years, and so we will love to hear your feedbacks. And to know how it's working in your also company. Voilà, a big thank you. And if you have questions, don't hesitate to come.